Hi, my name is Bhumanand Barik and welcome to my YouTube channel. Today in data science and machine learning context, we will be learning supervised learning. In supervised learning, we will learn about one algorithm which is known as linear regression. So basically, we need to understand when linear regression is required. Suppose in a data set, there are some features. Based on the feature, we need to find out the output. Already output is given for the given data. Suppose in future we are getting new data, and new data is containing those kind of existing feature. So based on feature values, what will be the output value that we need to estimate? In this condition, basically linear regression is required. I'll be giving you an example. Suppose the price of the house we have to predict, and the house data set is having different columns, different features. Different features are basically bedrooms, basically bathroom, how many what is the size of the bathroom, what are the facilities of the bathroom, how many bedrooms are present in the house, whether it is one bedroom, hall, kitchen, or 1 BHK, 2 BHK, or 3 BHK. So there are various features are present for the house. What is the size, lot size, what is the square foot, all these things are present for house. For all these features, certain values are present for each of the feature. For each of the features, certain values are present, as I told. So based on that, the price is also defined. The new data which is entering in the data set, if there is a change in the value of the existing feature for the new data, definitely there will be some of the changes can observe in output. So we have to estimate what will be the value of output if the value changes for the existing features. So all these things we have to see mathematically how it happens. I'll give you an example. Here, before proceeding for understanding the algorithm, we need to understand what are the independent variables and what is dependent variable. So suppose there is a data set and various columns are present. So this data set is house data set. Columns are like bedroom and bathroom. Third one is square foot. These are the columns. At the last, price. To calculate price, suppose this price is 50 lakhs. For one more row, price is 30 lakhs. This price column is dependent on what is the size of the house, what kind of bathroom is present in the house, how many bedrooms present in the house. On these values of these features, this price column is dependent. So if we make the changes in bedroom, definitely there will be a change, the change can appear in the price column. So here, as we can understand, all these bedroom, bathroom, square foot of the house, all these features are known as independent features. They can independently change. But this price feature or the price column output is not the independent feature. It is called dependent feature. So basically, if we plot the graph, in one side we have to keep independent feature. In another column we have to keep dependent feature. So we have to plot the graph between independent feature and dependent feature, and the graph can say us whether we should proceed with a single algorithm or any different algorithm is required for this situation or not. Here let's take a single feature, that is number of bedrooms present in a like house data sets. As the number of bedrooms are independent feature, so we have kept it in x-axis, and the price is dependent feature. Here, as we can see, it is kept in y-axis. As the number of bedroom is increasing, the price is also increasing. So the data set is something like this. The graph can appear something like this. So simply we can see here a kind of linear equation can be applied based on the graph which is appearing. So for 3 VHK we can calculate like something here or something like this. So like as the bedrooms are increasing, here the price is also increasing. Ultimately, to understand the graph, we are using the equation of linear mathematics, or linear equation we are using, which we all know is y equal to mx plus c. So we can understand here like what is known as y, what is m, what is x plus, and what is c. Here basically y is a function of x, as if x changes, the function of particular value of x, which is known as y is nothing but x changes in such a way so that it becomes y. So here y is ultimately a function of x. Here x is input or feature, y is output or target. To understand this graph, as we can say, how much x is changed which turns y. So suppose x here, what is x value or what is y value? Y value is if we multiply x with m, then we add a constant. This mx plus c simply turns y. So the y value is m times of this x plus c. Again, this y value, if we are considering, this y value again is something like this x value is taken and m is also multiplied with that plus constant. Constant is which is remains constant throughout the entire line. If we choose any particular point on this line, simply it falls into the equation category where x is multiplied with a particular kind of value, which is simply known here as m. M is the slope here. I will explain you what is slope. Slope is normally this line where the line is formed. The calculation, it is simply like y2 minus y1 by x2 minus x1 plus this constant. Constant is nothing but where it is touching y line, this value. For this entire line, entire slope, this is the only constant. Sometimes constant can be 0 if it passes through this point. So for this line, the constant is crossing the y here. It could be 1, so the constant could be 1 throughout the entire line. So for this equation y equal to mx plus c, a particular m value is found and particular c value is found. So here the question comes, how shall we implement this equation in the case of machine learning? So suppose we are having data in which various price is given for various bedrooms. If we got a new house which is having 4 BHK, suppose this is 4, this is 3, 2, okay, 4 BHK bedroom. As we know, there are various price defined for various bedrooms. Easily we can understand what is the price range of a 4 BHK. If the price range is already there based on the existing data, we can easily find out what is the price range for the new home which is having 4 BHK. Suppose we got a new house which is of 2 bedroom. Easily we can understand the price of 2 BHK here can fall in this category, which is ultimately lesser than the price of 4 BHK. So actually when the code is implemented, that time we need to understand how the algorithm works. So here I can say the dataset which we receive, that dataset has to be trained first and it has to be tested. Once the dataset is trained based on the existing feature, the algorithm will work in such a way so that the code will understand how much output is appearing for what amount of input. So based on that, it will understand the pattern of the data. Once the pattern of the data is understood, then it can be tested. And once it is tested, then the accuracy has to be checked. How much accurate is our model is. Once the accuracy reaches up to a certain level, then it has to be implemented. Then we can understand or assume that the model is giving us good accuracy, so that it will give us good result if we put new data in it. Suppose the data which we are having is having 20,000 rows. Simply these are 20,000 rows. Before implementing the algorithm in it, as the machine learning lifecycle says, it has to be divided into 2 parts. One is training set, another one is testing set. As we can see on the screen, now the 20,000 rows are divided into 2 parts. One is training set, another one is testing set. Each of this set is again divided based on dependent and independent feature. So from this training set, we have to find out what are the inputs and what is the output. Again from the test, we have to again find what are the inputs and what are the outputs. So input columns has to be checked and output column has to be checked. Again from the test data, input column has to be checked and output column has to be checked. As we can see here, in such case, suppose there are some 20 input columns. So 20 input features are there. One output feature. So here input feature is known as, suppose like X, and output feature is known as Y. Now train will be splitted into X train and Y train. Like that, test will be splitted into X test, Y test. There is a protocol. Normally most of the data scientists when they when they make a train test split as per Python, scikit-learn or R language, there is a method like train is given 70% and test is 30%, or train is 75%, test is 25%, or train is 80%, test is 20%, like that. The amount of data on which the training will happen, that has to be high amount, so that training will be robust, training will be more accurate. Once it is more accurate, then it can be tested on less amount of data. So once the algorithm is implemented, or the code is implemented, as we can see, for each and every data there will be a point on the graph. If it is represented mathematically, for each data there will be some point will appear here like this. So there will be various points can appear for each and every data. Okay, now from these points we have to find the exact line which will be our linear line. We can find this line, we can find this line, we can find this line, we can find this line. So there will be n number of lines out of these points. So what will be our best fit line? On that best fit line our entire algorithm will depend. So if here we calculate a different line which is quite good for some amount of data, but it is not good for other data, or while training it is quite good and while testing it is not fitting well, so which can lead to overfitting option. So that we need to understand how to get a best fit line. So for this video I am not explaining that one. I will be preparing a different video on how to get the best fit line. Then we will be checking the math behind getting a best fit line. So the moral of the linear regression is to get best fit line. Which can be applied for every data. So if from the trained data set we are getting a best fit line, that best on the base of best that single linear regression best fit line, the testing data can be checked, and once it is checked we have to find the accuracy. So accuracy has to be checked. How much accurate is it? Whether it is 97% accurate, or whether it is 85% accurate. If data is 97% accurate and one score is 85% accurate, definitely we have to consider that 97% model. And sometimes some of the models are like 100% accurate. So if any model is 100% accurate, we can understand something somewhere fishy in that model. We have to recheck. Because if everything is fine, if everything is perfect in data science, we can come to know like somewhere something is leading to a wrong direction, which can cause overfitting option. 97 it is okay, 98 also it is okay, and if we are getting a value like less than 60% or 70%, without implementing data science or machine learning like algorithms also, we can get 60% or 70% accuracy. You can while giving demo I'll show you like how the models are performing without implementing machine learning, just by simple common sense. It is simply giving 60% accuracy. So what is the requirement of machine learning algorithm here? Machine learning algorithm means it has to be precise. So accuracy plays a major role in understanding like how proper our model is. So thank you so much for watching this video. I hope you are able to understand what I am trying to explain. Please share this video and subscribe my channel. Thanks a lot.